Hello everyone and welcome to We Meet at Digital Days. My name is Lisa Richter and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Sonnenwagen, Tech Talk with Team Sonnenwagen Aachen. Our speakers are Kai Smith and Lina Swearing. They will hold a presentation and will answer your questions later. Before we start, I would like to point out one thing. You'll be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long, and the chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all of your questions promptly. At the end of the webinar, you'll be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our event. You will receive the link to the presentation in the next few days, and the recording will be available at our website shortly. So now I will hand over to our speakers, and I wish you an exciting presentation.
Hi everyone, my name is Lina Swearing. I'm part of Team Sunwagon since December 2019. I'm currently a student at RWTH Aachen, and today I'm here with my partner Kai to tell you more about our project that we are doing as part of our studies here at RWTH. Yeah, Kai, go ahead and present yourself.
Yeah, so hi, my name is Kai Smith. I study electrical engineering here at RWTH Aachen, and I've been with the Sonnenwagen team since 2018, and now I'm the head of the electrical department, and I'm happy to be here.
Yeah, so Sonnenwagen, what is this about? We are a team of students from RWTH and FH Aachen, roughly 45. And we were founded in 2015 by a bunch of students who procrastinated a little bit during their exam season and thought it would be an amazing idea to found a club that will do racing I apologize for the dogs. This is my neighbors. This is, I guess, online, right? So I can't do anything about it. Yeah, sorry. So we are all prospective engineers and researchers, and we really want to push the technical feasibility of creating a car that is solely powered by solar power. And with it, the goal is to participate in the World Solar Challenge in Australia, which is a race of 3,000 kilometers through Australia, from the very north of the continent to the south. That means that all our technology is tested under extremely difficult conditions through the Australian outback. As you can imagine, it's pretty hot, and the sun is blaring. So yeah. Of course, with such a huge project, we need all kinds of different departments. We have the chassis team, the structure, the aerodynamics, which are hugely important for us. And in the background, we have sponsoring, marketing, and logistics. And of course, the electrical engineering team, which Kai will tell you a lot more about. As this project, we understand ourselves as a flagship project, which means that we bring technology that is not yet on the market, but is in development into reality, combine it all to create the most efficient, most future-thinking car possible, and kind of show what future mobility can look like. Yeah, a little bit more about the World Solar Challenge. It has 3 classes, and we are participating in the Challenger class, which is a class that is solely focused on performance and maximum energy efficiency. As you can imagine, the car is not comfortable at all. You've seen the pictures. It's completely aerodynamic. We do not focus on anything that is in regards to practicability and acceptance, because we really, really want to push the technology forward and make it as efficient as possible. The competition itself consists of roughly 50 teams from 24 countries. And most of these teams are from well-known universities such as Stanford, Delft, Michigan. So you can see from all around the world, student teams are building those cars throughout 2 years and then come to Australia to compete. And Sonnenwagen is in fact the only German challenger team. And yeah, our last solo challenge was in 2019. After 6 days, we made it to the finish line, which was amazing because we had an accident along the way. And we pushed through it and we placed 6th out of 27 teams, which was simply an amazing experience. And I think it had a lot to do with the improvements that we made from our first to our second Sonnenwagen. We increased our average speed from 60 to 85 kilometers. So you can see these are speeds that are definitely street worthy. It's not going necessarily slow or anything. In fact, we can have maximum speeds of up to 145 kilometers per hour, which I think speaks for itself in regards to the aerodynamics of the car, which we were able to decrease by 50% from our first to our second car. And all these achievements were recognized in the awards that we received because of our swift reaction to the accident and simply the way we pushed through this challenge. We received both the Spirit of the Event Award and the Safety Award, which we took gladly home. And it was an amazing experience for the team that was down under. So as I already said, we have already built 2 Sonnenwagen. The first one was the one that was built in 2017. It was built with 0 back-end structure. I was not part of the team back then, but I can only imagine that it was very, very challenging to create a Sonnenwagen from virtually nothing. They decided to make a shape of a catamaran, which is due to the aerodynamic requirements of the car. And it was quite large. It had a measurement of 4 meters 25 to 1 meter 70, and it was quite tall with 1 meter and 1 meter 1. And it had a front area of 1 square meter, and the solar area was 4 square meters, so quite large. And if you compare that to our second Sonnenwagen, the front area as well as the solar area is decreased significantly, and they look completely different. One is a catamaran and the other one is a bullet, which we call Pfeil in German. And yeah, that explains all the improvements that I explained earlier. And now what we're doing currently is we're building our third Sonnenwagen. We finished developing it at the end of 2020, and we're currently in the manufacturing. And of course, I'm not presenting you any pictures of it today. Because it's supposed to be a surprise and we don't want to give anything away to our competitors. But yeah, we're currently in the process of manufacturing. I'm going into the workshop tonight, and it's all very exciting to move forward. However, as you can imagine, Corona shook things up for us as well. We had to completely build the Sonnenwagen 3 online. Everything was done in home office. Which was challenging and to be honest, also a bit sad. We have a small office here where usually we would meet up and, you know, become creative and get to work together. But it was amazing to see as well how the team nonetheless got together. We organized team events, we organized focus groups online. So it was a challenge, but we pushed through it. But then the massive drawback came when, unfortunately, the World Solar Challenge 2021 was cancelled by the organizers in Australia. I think that for us was like a very low point. Simply, as you know, the Australian Corona regulations are extremely harsh. They're managing well, but that was a drawback for us. Yeah, and so that was really a low point for us. However, again, we are so lucky that we call ourselves part of the solar family, and I brought you the slide just for you to understand how many teams there are in Europe alone, and all of them got together and were like, no, we still want to race in 2021. Corona will not beat us. And we got together with lots of these teams and decided that we are going to organize our own solar challenge this time. We decided to have a special edition of the European Solar Challenge in 2021. That usually takes place in Belgium and will take place in Belgium this time as well, in Zolder on the racetrack. And of course, our goal there is to become first place. It's like the dress rehearsal for our new Sunwagon. That it's very exciting because that's the first time that the new Sunwagon will be on the road, on a racetrack, participating in a challenge. So yeah, it's exciting to see it in real life then, and this is what we are pushing for. And then we also have a new solar challenge organized. I can already tell you it's organized, it's happening. I cannot tell you any more about it. It's a little secret that we're keeping, and if you want to know more about it, then go back to our social media or something like this in a couple of weeks' time, where we will announce together with all the other European teams what is going to take place. And then, yeah, there, of course, we're also in it to win it. We do not participate in it. Well, we participate in it for fun, but we also want the challenge. So our goal is definitely to make the first place there as well. And we believe we can do it. Otherwise, we wouldn't participate. And then looking even further into the future, we also want to have a top placement in a solar challenge in 2022. Those are taking place in the US, in Chile, and South Africa, so there's loads to choose from, and we are very excited to have our Sunwagon 3 there as well. Yeah, now I'm handing over to my colleague Kai, who will tell you a lot more about all the technical aspects of the car.
All right, thank you. So, long time no see. So before we focus on the electrical components, which I know we are all most excited about, I want to get into some interesting mechanical details of our Sunwagen first. So as you've noticed by now, we want our solar car to be as efficient as possible. During the race, the aerodynamic resistance makes up the biggest portion of the driving losses. So therefore, we put very much effort in optimizing the outer shell and find an optimal form subject to a list of constraints, because at least every component has to fit in there, and the driver as well. So we go so far that the car can even use side winds to propel itself forward. This effect is called sailing. So, and on the left side, you can see the iteration process we went through for the Sonnenwagen 2. So, to be able to sail, it is necessary that the wind comes from a specific direction. To be independent of this direction, our car can tilt its body on the road while driving. This works by setting a different steering angle for the front and the rear wheels. This is called crab steering, and it was a huge challenge for our chassis team. But in the end, this resulted in a big portion of the mechanical parts being self-developed and custom-made, as you can see in the right picture. So, weight is another factor that has an impact on the driving losses. On the slide before that, you could see that we built the chassis ourselves, and even with the structure, we try to be as lightweight as possible. So the outer shell and the so-called monocoque is made from carbon composites. We have been inspired here by motorsport applications, where these means of manufacturing are well established. The design of the carbon fiber layup is complex, though, and especially safety critical parts such as the roll bar need to be thoroughly simulated. Altogether, this means a lot of work, and it is impressive for every member to see that this car exists and it can drive. It is amazing. So once the car is built, the journey has just begun. So during the race, or when we arrived in Australia, the team must be able to communicate with the driver and other convoy vehicles during the race at highway speeds and we cannot stop because stopping means losing time, which is crucial. Additionally, to build an efficient car does not win the race. One has to drive efficiently as well and consider the limited charge inside the battery, the sun irradiation, and the slope over 3,000 kilometers. These are the tasks of the driving strategy, which are preparing continuously for this challenge. So as you've seen, our project consists of many tasks, and of course, many people are needed for that. This is especially true for the manufacturing of the car. So on in the left picture, you can see the results of a night shift some 2 years ago, and during Corona, gathering of large groups is simply not possible. So we had to find a way to still be able to continue. So we needed a different concept, and our concept in the workshop is that we partitioned the team into pairs that each see each other only exclusively. During a shift, respiratory masks and keeping distance where it is possible are naturally mandatory. Being only able to work in small groups means that we started the production earlier and started with night shifts right away. And there's a lot of work to do, but we have a mission, and the car will be finished, even though Corona is here. So let's get finally to the electrical part. Our project is very dependent on our value partners. One of them is Würth Elektronik. We have been working together since 2018, and even in Corona times, we could organize a webinar together where the topics have been individually selected for us. This was, of course, online, but by now we are all accustomed to that, and it was a very good experience, and we took a lot from there. What we cherish about our cooperation is the super easy ordering process, even with small quantities. So sometimes we have a very spontaneous way of identifying mistakes or problem, and Würth Elektronik has always been there for us, and it supports us a lot. Also, we are in touch with experts from them, and we can address questions to them spontaneously how we want. So another benefit is Red Expert. This is not exclusive for us, but it is a powerful website program nonetheless, and it's free. It can help selecting the right electromagnetic components and analyze filter behavior, similar to known SPICE software. If you don't know it, you should definitely check it out. It helped us a lot. So here you can see a generalized wiring diagram of our solar car's electrical system. This is kind of a lot to go through with that. So in comparison to regular cars, we have much less components. The main part is the powertrain, which I've highlighted in yellow, and it consists of the solar cars, the solar cells, the battery pack, the inverter, and the motor. All components are together or jointly connected in with the 12 volts power supply and a single CAN bus. We don't have multiple CAN buses. The amount of data we have is so little in comparison with OEM cars that we only have one CAN bus. Additionally, in the electrical engineering department, we design most of the components ourselves to achieve maximum efficiency. And in those components, we can find a very high count of Würth Elektronik products. So so things I will not go too deeply into is, for example, the main system control unit, which sits in front of the driver and evaluates the inputs that are given into the steering wheel, and yeah, and process the data and forward it to the different control units in the car. So if the driver wants to accelerate, the system control unit sends a command to the inverter. So with respect to the time, in the following I want to focus on the powertrain. So the most prominent component by far, I'd say, are the solar cells. These are perfectly embedded into our outer shell, and during the race they make up our sole energy source. In 2019, we used gallium arsenide triple junction solar cells, which are used or which are found in space applications and have been adjusted to the terrestrial spectrum with a cell efficiency of up to 35%. The challenge here is twofold. Firstly, the arrangement of single cells has to be determined. This lies in contradiction with a perfect aerodynamic design and needs evaluation. So for example, it is the best for the solar cells if they are always aligned perpendicular to the position of the sun, but the aerodynamic would like to have a very round shape, for example. So there's a trade-off. Secondly, after the arrangement has been fixed, an ideal interconnection of cells has to be found to maximize the energy income over one day. Hereby, the income is highly sensible to the sun's path in one day. So in the lower left corner, you can see an image of our Mppts. And to explain what Mppt does, it draws as much power from the solar cells as possible and pushes them onto the voltage in the high voltage grid. And in 2019 we used 9 Mppts of those in parallel to operate each string of solar cells as efficient as possible. So this is very complex. So to the battery, our Sunwagen is equipped with an approximately 5 kilowatt-hours battery in size. In comparison to regular electric vehicles, this is dramatically small. The reason for this is that the total cell mass is restricted by the regulations of the World Solar Challenge, which makes this challenge an efficiency race and not a capacity race, which is the whole point of it. So in the given boundaries, we optimize the battery for the maximum achievable capacity and the smallest weight. Also, we manufacture the battery ourselves. So, for example, in 2019, we used more than 400 cells of the form factor 18650, and for the next season, we've been building a BMS, which we have adapted from another befriended students team. So there are changes incoming. I'd say the most central part, if one can say so, is our motor. It is designed as an Ironless, permanently excited synchronous machine in axial flow form. It is fully integrated into the right rear wheel, so directly behind the driver, and because of this design, it does not need a gearbox, which increases the efficiency further. The specialty about this motor is that the magnets are arranged as a Horbach array with magnetic flux densities of more than 1 Tesla. We have designed and manufactured the enclosure halves for the motor and the coil ring ourselves. And on the right hand side, you can see the process of pouring the resin for the coil ring, which sits inside the motor. Through the right selection of resin in last season, we were able to increase the operating temperature to above 160 degrees Celsius. Furthermore, there is another very exciting project in our house about power electronics. In a master thesis last season, a highly efficient 3-level inverter has been developed, and it has a theoretical efficiency of more than 99.5%. The specialty here is the use of gallium nitride semiconductors, which allow way higher switching frequencies and power densities in comparison to ordinary silicon devices. The new inverter enables us to adapt passive components in size due to the higher possible switching frequencies, and because we have the control about software, we can use a sensorless field control mode for driving. There are many more applications in the electrical department and projects we are following, but this should be enough for now. So we also brought some pictures for you, so you can see what the whole challenge, apart from the electrical or mechanical design, is all about, because it is a challenge and it's about people.
Yeah. This is where we became best newcomer in the World Solar Challenge 2017. So this was the first time we participated as Sunwagon, and you can just see what it looks like to be there, to camp outside and to build a car. And then the European Solar Challenge is a 24-hour race in Belgium on Zolder. Back then in 2018, it rained continuously, so that was a huge challenge, but it still shows that even though it rains and it's not as beautiful in September in Belgium, solar race is still possible. Here you can see the process of manufacturing the second Sonnenwagen in 2019. And then, this is also a very exciting moment for us, which we're looking forward to do again this summer, is the rollouts. We are presenting our Sunwagon to the world, which takes place in the summer. And back then it was really exciting to finally reveal what we've been working on for 2 years in a row. Then, as I already said, in the World Solar Challenge 2019, we placed 6th, and it was as well an amazing experience to drive these 3,000 kilometers, endless roads, and to just be down there and race against all these teams from all around the world. So from me as well, thank you so much for your attention, and if you have any questions that you want to know about, you can simply ask them in the chat.
So thank you very much. This was really interesting for us. And yes, like you already mentioned, we will turn our attention now to your questions. So let's have a look. I think there is already a first question. Why did you choose Ironless motor? What is its efficiency and weight?
So I think I'll take on this question. And to be honest, I don't know the value of the efficiency and the weight by heart. So but we've chosen the Ironless motor design because it can be integrated into the wheel because of this compact form, and it's actually an established form that also other teams use. And yeah, and concerning the efficiency and the weight, I think the weight is less than 10 kilograms and the efficiency is higher than 95%. It depends what peak in the efficiency map you are choosing, but I can get back to that and send you the most exact numbers that we can publish per email.
That sounds good. I think so. We can go to the next question. Do you have activities for technology transfer so that industry can learn from your results?
So far we don't have those those programs, but we stick tight to our partners, and in the end all what we do is the sum of the experience that we make, the experience of the institute at our university, and the expertise and experience that that our partners bring into the project, and we try to hold this knowledge together, and yeah, and because we have competitors in the field, and we want to keep an edge above them.
Okay, great. Yes, I think the partnership is really important here. So you've got a lot of communication here with other companies.
Yeah, for sure.
So,
like for example, the webinar that we held together with Würth, that's not only one way. It's always an amazing exchange for us, and I hope the partners too.
yes, I think so. So there's one more question. How do you solve the refrigeration and ventilation for the cockpit habitacle?
Yeah, I don't know this actual word, but I think it is about that that a windshield can get very foggy when it's cold outside, and we have such a curved glass that we can't put these wipers on there, and it wouldn't be efficient nonetheless. So in Australia this is not such a big problem because it is very hot, and we don't drive at night. But in an event like the European Solar Challenge in Belgium, which is a 24-hour race, we also drive through the night, and the windscreen can get foggy. So we have a special spray for this case that limits the amount of fog that can that is being created there. And additionally, we have a very small fan which the driver can activate or deactivate, that is blowing a little air stream across the windscreen panel. But it's not the design focus, it is not so comfortable. So
no, if you ask our drivers, I think they're the ones who sometimes suffer the most. In Australia, 2 hours in this heat. I wasn't a driver, so I cannot imagine. But the drivers really sweat a lot. It's not comfortable in there, but they're doing it for the team, I guess. So ventilation is really minute. It would have a huge impact on our aerodynamics, so they just have to suffer through. And to be honest, in Belgium, sometimes it's also just the hand wipe to clean the fog away. So this is not something we focus on.
Okay. And there's one more question I think there are more people interested in. When will you present the new Sonnenwagen?
So that's the 19th of July. Now you're putting me on the spot here. July, right? It's not June. It's July, 19th of July. I should know this by heart, but I do not. It's the 19th of
Time is running. Huh?
Yeah.
Kai, help me out here.
Yeah. You're totally right, but we cannot guarantee that it will be on that day, just because Corona can lead to some changes.
Mhm.
But it might be in July. So yeah.
Yeah. It's
Yes.
definitely it's 19th of July.
Okay, great.
You
So
putting
wish
you
you good luck for this.
Yeah, I mean, for sure. Come, yeah, I confirmed just now. It's 19th of July. It will be held as a hybrid event. We are hoping to make it as like offline as possible, but of course it's going to be hybrid. So for sure, there's going to be a online presentation. Just follow all our social media and everything. We are also sending out invitations to Würth as well, so that you can participate in the rollout.
Really great. So I think I just have to say thank you. We are really proud being part of such a great project with you. And thank you for your presentation. And yes, now we can finish this. If there are any questions left, we will answer them via email afterwards, or you can send us the question per mail. Thank you very much for your attention, and I hope you enjoyed our presentation. And the next presentation topic is how to design a transformer for manufacturing. And yes, see you there and enjoy our digital days. Goodbye.
Yeah. Thank you so much for having us. And yeah, if you want to know anything more, you have our contact details. Just send us a message, follow us on all the social media, send us messages there. Feel free to contact us at any point.
Okay,
Yeah.
great.
Bye.
So, bye.